Hey everyone, so we're still in section 4.3. I'm on page 369. Okay, so now we're going to talk about perpendicular lines, which before I can do that, I just want to refresh your memory as to what it means to be the reciprocal of a number. So we're just going to state the reciprocal of each one of these. So the reciprocal, it's easiest just to show you an example. The reciprocal of 2/3 is 3/2. So it's literally just the idea of flipping the fraction. So if I had, say, something like 5/2, you would tell me that the reciprocal is 2/5. And maybe you should just try these two on your own and hit play when you're ready. So the reciprocal of 3 would be 1/3. And then the reciprocal of 1/7 would be 7/1, but we wouldn't write it like that. We would just write 7. So make sure that you just write it as 7. Okay, so we need to know just the concept of the reciprocal so that we can talk about perpendicular lines. So what we say with perpendicular lines is that they have opposite reciprocal slopes. So opposite can also mean, so maybe I'll just say negative. So however you want to think of that. I think of opposite, some people think of negative, it's up to you. So once again, I want to do this same kind of goofy exercise where we just write any equation of another line that is perpendicular. So I've got y equals 2/3 x plus 4, and I just want any equation that would be perpendicular to this. So once again, you have to know the slope. So the slope that we have here is m equals 2/3, but what we need now is m equals -3/2. So I actually think it's really good to write this level of detail out for yourself, because a lot of times what I see is when people go through this, they go through this so fast they forget something. So you kind of slow yourself down and write down some extra details. Okay, so any equation that would be perpendicular would just have this slope -3/2, and then I can just add whatever number that I want. So I could add a +7. I don't know, what if I added a +13? Totally doesn't matter what this number here is. All that matters is the slope once again. So the structure of these types of perpendicular lines would have to be this plus any number. Okay, so I want you to try that with the next two. Pause, hit play when you're ready. Okay, so for B here, so here's where my M is. So I have the slope -1/3, and I need m equal to 3. Okay, so then the structure of my line, so I'll just kind of cut to what it would be. 3x plus any number that you wrote down would be fine. So as long as it's got the slope of 3, it's going to be perpendicular. Okay, now thinking about x equals 4 here, so again, this is that special situation, right? 1, 2, 3, 4. So here's my line. This is x equals 4. So just thinking logically, if this is a vertical line, what would be perpendicular to a vertical line? Well, a horizontal line. Any horizontal line would be perpendicular, right? And the structure of these would be y equals any number. So now for perpendicular lines, horizontal and vertical lines, they are perpendicular to one another. Okay, so now I want to think about how do I write the equation of a line that is perpendicular to another line. So it's really the same idea. So you still need to determine the slope that you need. Then you need to use the given point. And then you want to put this information into the y equals mx plus b or the other form. Okay, so taking a look at these two examples just to make sure we've kind of got it. So I've given you a line, and I want you to find a line that is perpendicular to this given line that goes through this point. So for this first example, so here's my slope. So I usually like to write this out. The slope I have is -2/3, but the slope that I need then would be +3/2. Make sure that that looks nice and clear for you guys. So just notice how I wrote this out and forced myself to think through the details. I am a huge fan of writing out lots of detail. And now from here I can go ahead and I'll use my y equals mx plus b form. So let's see, this will be 4 equals 3/2 times 0 plus b. So what I get is that my b is just equal to 4. So then this is going to be y equals 3 over 2x plus 4. Okay, and now moving on to the second one. So what is my slope in this case? Well, the slope that I have is m equals 1/2, but the slope that I need in this case would be m equals -2. So you want to, again, think through what is that actual structure of the slope you need. Then you've got your slope and you've got your point. This time I'll use my point slope form. And I'll plug in my information. So I get y minus 5 equals -2 times x minus 4. So I need to ultimately get this into slope-intercept form. So let's see, I need to distribute. So this will be y minus 5 equals -2x plus 8. And then I'll go ahead and I'll add 5. So I get y equals -2x plus 13. Okay, so that's the idea now behind perpendicular lines. So now I want to pivot to something that tends to be a little trickier. So we're going to go through like a full exercise of how to find parallel and perpendicular lines when the initial line is in standard form. So this is definitely a little bit of a longer exercise, so I want to be nice and thorough so that you have something to refer to when you have to work on these. So what I want to do is, this exercise says, write the equation of a line that is parallel to this one, goes through this point, and your final answer needs to be in standard form. So these are kind of a couple of key things that we have to keep in mind. Now, in this example, the given line is not in slope-intercept form, so therefore this equation, this 2x minus 3y equals 6, we have to put this into slope-intercept form. So first let's do that. So how do I get 2x minus 3y equals 6? How do I get this into slope-intercept form? I solve for y. I'd highly recommend you pause the video and solve for y just to kind of engage with this example a little. Hit play when you're ready. So I'm going to go ahead and I'm going to subtract off the 2. So I get -3y equals -2x plus 6. Divide each side by -3. And I get y equals, this becomes positive 2/3 x minus 2. Okay, so notice that I just had to do a whole bunch of work to figure this out, but there's only one piece of information that I really need to know here. I just need to know what is the slope of our given line. And this is really the piece of information that I need, right? So the slope of our given line, we want to just note that to ourselves. The slope is 2/3. And now we must determine what kind of slope the actual answer needs. So, rereading the problem, do we need a parallel line or do we need a perpendicular line? And this is where you have to go back and reread the problem. Going back, parallel line, that's what we wanted to find. So I need to use the same slope. So given this information, what will be the slope of our answer line? So the slope of our answer line needs to have m equals 2/3. So I had 2/3 as the slope, and that's what I have to use because it's a parallel line. Alrighty. So now, notice what I've got. I've got my slope, so maybe I'll just kind of point out all the information. I have this slope, that's what I need, and coming back up to the top, I have this point. Those are now the two pieces of information I need to finish this exercise. So now we're going to create the equation of a line using this information. So maybe you want to pause the video here and finish the line. Hit play when you're ready. So I'll use my mx plus b form. So I have to remind myself what that point was. Let's see, it was -12, 1. So I'm going to plug in 1, 2/3, -12 plus b. Okay, so remember, if you don't know how to multiply these together, so you can always write this off kind of on the side. Do a little side calculation here. So this is 2/3 times -12, so that would be -24/3, so this would be -8. So I'm just going to write that over here. So this is 1 equals negative 8 plus b. Add 8 to each side, so I get b equals 9. Okay, so now I get y equals 2/3 x plus 9. Am I done? No. Now you've got to reread the equation again. Remember, we wanted our answer in standard form. Also, I even remind you down here, I say standard form down here as well. So we have to now get this into standard form. So first things first, I'll just go ahead and subtract off the 2/3 x. If you wanted to get rid of the fraction first, that's fine too. Doesn't matter which order you want to go with that. So now I just have to multiply by the LCD of all my fractions here, which would be 3. So now I just multiply everything times 3. And ultimately this becomes negative 2x plus 3y equals 27. So there's all the work for that particular solution. Okay, so I know that's a lot, so this actually seems like maybe a good place to pause the video. So I'll catch you guys in the next one, and we'll continue on with this topic in the next video. Thanks for watching.